Algebra 2, Chapter 2, Section 7, Parent Functions and Transformations. So, there are all kinds of graphs that we'll come across. In one of the previous sections, I think it might have been the last one, you learned about weird ones like step functions and piecewise functions. So, we always try to figure out generic families of graphs, and that's what we're kind of talking about here today. A family of graphs is just like a group that all have similar characteristics. Like a quadratic is always a U shape, right? That's how I can visually see. Bam, that's a quadratic. Cubics are always like this weird like sideways S shape, even if it's going down. Sometimes it's very flat and it doesn't have much of a curve, but I can still recognize it as a cubic. There's other ones like the square root function or the logarithm function. Those two look very similar, but they are very different. I can visually spot which one it is just by looking at the graph. And that's what you're trying to develop right now is the way to just visually look and see and understand what kind of graph you're looking at and what that implies. So a couple of things that you probably already know. A constant function, that is when you have yourself a nice horizontal line, and it's always of the form y equals a number. So whenever I see a horizontal line, y equals a number. I know what it is, I just have to figure out what y coordinate it's going through, and I know almost everything I need to know about that function. You can also have linear functions, which is anything that is a straight line, as long as it's not going straight up and down, because then it's not a function. But that you can think of that kind of like a constant function, but it's you just say a constant relationship. But here, anytime I see something going up left to right, down left to right, in a straight line, I know I've got myself a linear function. And particularly, if I've got something that's going through the origin with slope 1, with the equation y equals x, we call it the identity function. Because it's like every input is the same as the output, so it's kind of boring, but an identity function is very much like a linear, but it's got a special slope 1 and y-intercept 0. Right. Absolute value functions, whenever I see straight lines turn at a sharp point, that screams in my head, absolute value function. I don't even need to know what the equation is. If you draw something like straight lines like that, I see absolute value. Which is why, if you remember back in Algebra 1, when you were drawing quadratics, which have the nice U shape, the teachers always said, make sure you don't make a V shape out of it. Because the V shape is absolute value. The U shape is a quadratic, right? So that's why we always try to get on their case, and we marked you off if you drew too sharp of a turn there for your quadratic, because what you were actually drawing was an absolute value function, and we don't want that. All right. But the big difference between absolute value and quadratic is nice and rounded and smooth. Absolute value changes direction abruptly. That actually makes a big difference in things like calculus. All right, but we're not in calculus right now. All we're doing is trying to identify the function given the graph. So I see straight lines making a sharp turn. That it immediately yells at me, this is absolute value function. Nice, I've classified it. That's all we're trying to do is just classify it. I don't have to figure out what the equation is or anything like that. Though, I mean, I could, but we're not doing that right now. Here, this is a nice horizontal line, right? So that meant it was a constant function. So all you're doing for some of these problems is looking at a graph, figuring out what kind of function it would be. Now, one thing is it might also give you an equation. You got to know what the basics of each of these equations look like. Constant y equals 1, absolute value, you got to have the absolute value bars. An x squared is always going to give you a quadratic. I'm going to throw linear in here as well. If you ever have anything like a linear, you should be able to identify, oh, that's a linear function. All right. So those are all parent functions for families of graphs. And we call them that because all the other graphs in that family are based on them. And the way that they are based on them is we do translations. And we'll talk about that in the next video.